In the arid deserts of the Middle East, the leopard gecko is a highly efficient survival machine. For millions of years, it has evolved to extract a precise balance of proteins, fats, and minerals from a chaotic, crawling ecosystem. That evolution is interrupted when we bring them indoors. A sterile 12-square-foot glass terrarium replaces the vast, interconnected resources of a natural landscape. These reptiles face a strict biological constraint. They are obligate insectivores. Their digestive tracts lack the enzymes needed to process plant matter, meaning every vitamin they require must be pre-processed by the insects they eat. Captivity severs the ancient nutrient supply chain. The wild insects that spend their lives consuming mineral-rich desert flora are gone, replaced by whatever we provide within the four walls of the enclosure. Moving a wild predator into a glass box dismantles the biological infrastructure required to keep its cells functioning. Many caretakers attempt to solve this by feeding their geckos plain insects directly from a pet store bin. Insects kept in transit or in plastic tubs are often nutritionally hollow. Without a recent, high-quality meal of their own, these bugs offer empty calories while lacking critical minerals like calcium. This nutritional void leads directly to metabolic bone disease. MBD is a systemic collapse that occurs when the gecko's bloodstream runs out of dietary calcium. As shown in this X-ray diagram, the body prioritizes basic nerve function by pulling calcium from the skeleton. The gecko's own system cannibalizes its bones, leaving them frayed, fragile, and eventually unable to support the animal's weight. This skeletal decay results from a breakdown in logistics. It occurs when the human caretaker fails to replicate the mineral cycles that exist naturally in the wild. To prevent this physical collapse, we have to carefully bioengineer the gecko's food supply from the inside out. We solve this by using feeder insects as biological Trojan horses, vessels designed to deliver hidden payloads of nutrients directly to the gecko. The process starts with selecting the right chassis. Dubia roaches and crickets offer the best protein-to-fat ratio, providing a foundation for carrying additional nutrients. Using insects caught in the wild introduces variables we cannot control, such as parasites and accumulated pesticides. We also avoid waxworms. Their extreme fat content triggers obesity and a refusal to eat healthier, staple insects. To turn a standard insect into a nutrient carrier, we use a technique called gut loading. This involves feeding the insects a concentrated diet of vitamins shortly before they are offered to the gecko. This cross-section illustrates the critical 24 to 48-hour window where the insect's gut is packed with squash, sweet potatoes, and dark leafy greens. The bug's digestive tract becomes a storage facility for the vitamins the gecko needs. This step transforms a nutritionally empty insect into a targeted delivery system for essential minerals. Beyond the internal payload, the insect also requires an external coating of chemical armor to be fully effective. Our dusting system uses plain calcium and calcium with vitamin D3 to transport calcium into the bloodstream. Babies need this dense timeline of daily minerals for rapid skeletal growth. Adult requirements shift, needing this reinforced diet only every third day to maintain bone density. Maintaining this age-specific schedule provides the defense necessary to prevent skeletal failure. When the gecko consumes these engineered insects, its body finally receives the materials it would normally find in a desert landscape. This macro view shows the result of a functional supply chain, a thick, firm tail. In a leopard gecko, this tail serves as a specialized storage unit for surplus energy and nutrients. Zooming out from the terrarium, we see the caretaker's role in a new light. Human intelligence effectively replaces a planetary ecosystem, calculating precise mineral dosages to ensure a small reptile thrives thousands of miles from its natural home. Managing these logistics is what keeps the animal healthy. To find the exact feeding schedules and equipment lists for your gecko's age, visit the Krawlo diet guide linked below.